What's the other F word? Functions. Today we are learning about functions. All right, let's focus in because today is going to go even faster than yesterday's homework, okay? Super easy. Super easy. A mathematical relation exists when two mathematical values are related in some way. A relation, we learned yesterday, is any set of ordered pairs. Is any set of ordered pairs. What is the set of x coordinates? What did we learn yesterday? What's another name for the set of x coordinates? The domain of the relation is your x coordinates, and the y coordinates are called the range. Relation. Okay, so just like yesterday, we can write things as ordered pairs. We can put them in a table. We can make a graph. Something that's new is this mapping. Okay? Your input is also your x's. And so if your x was -2, you follow the arrow. What's your output or your y? 3. Your 0 is your input. Your output is -1. So you just follow the arrows to make your ordered pair. Okay? It's just a different way of showing you. Today we're learning the F word. A function. I know, because Miss Hopp's funny. You guys just don't realize it. A function is a specific type of relation that assigns exactly one output to each input. Okay? So a function, it doesn't have to be straight arrows, but there's only one arrow coming out of every input. It is not a function if there's 2 arrows. Let's write that down so we remember. X cannot repeat. You cannot use the same number for x more than once. Only one arrow out of each input or x value. Okay? Your input cannot repeat. And you can only have one arrow coming out of each x value. We're not really going to have to look at that much, right? Well, some of you couldn't. I was standing in front of it, sorry. So a lot of these are just going to ask us, is this a function or is it not a function? So if we look at this one down here on the bottom left, don't anybody say it out loud. How many of you say, yes, this is a function? How many of you say, no, this is not a function? Okay, Sam, why no?
Because they're not straight.
Doesn't matter if they're straight. Petro? Which one? Which number repeats? Your input of 1 has 2 arrows coming out of it. So not a function. The input of 1 repeats. Your input or your x cannot repeat. Your input or the x, they mean the same thing, cannot repeat. So if we look at the bottom right, again, don't say your answer out loud, but everybody get your answer. The bottom right. If I slide over here, how many of you say yes, function? How many of you say no, not a function? Zayden, why not? Liana, why not? The 4 repeats. Not a function. Input 4 repeats. Liana, how did you know that 4 repeated?
Because it has like 2 arrows going.
Perfect. There's 2 arrows coming out of here. If there was only 1 on all of them, totally fine. Totally fine. You only have to worry about your X's or your inputs. Stop. Okay? Let's flip it over. We're going to continue to deal with functions, but now they're going to give it to us in a table format. Okay? If this was my input or my X, and this is my output Y, which one do I care about? The input. I don't care about the output. So we look at our input. Is this a function, yes or no?
No.
Why not? How do you know if it's a function? What is this? What did we say? X cannot repeat, and only 1 arrow coming out of each. We don't have a map, though. So we go back to this. Do any of your X values repeat?
No.
So is this a function?
Yes.
Yes. This is a function.
I just write yes function.
Your X values cannot repeat. So go to the table on the right. Do we care about X's or Y's? X. Scribble out the Y's. I could care less about the Y's.
No function.
Why not a function? What number repeats? 2. Very good. So not a function. Input 2 repeats. Input 2 repeats.
You have to write all that.
Everything depends on the X. Do we care about the Y today? We don't care about the Y. Completely ignore the Y. But sometimes they're going to show us the graph. So to determine whether the relation shown on a graph is a function, we apply the vertical line test. VERTICAL. Vertical line test. And to help you remember, we're going to draw a vertical line. Vertical lines run up and down, just like the y-axis. If for each value of x, a vertical line passes through no more than 1 point on the graph, then yes, it represents a function. If the line passes through more than 1 point, it is not a function. You know the best thing to represent a vertical line is your pencil. So if everybody puts their paper, I'm going to steal Sarah's for a second, just lay it flat on your desk, straight up and down like this. Okay? Take your pencil, lay it against your paper, running up and down like your y-axis. Start way over on the left side of this first graph. The vertical line test says, if I slide this across and I touch the graph more than 1 time, not a function. So if I slide your pencil across this, will it touch my graph more than 1 time? Right here, you see it touching the graph twice. If I have this vertical line, it's not going to be perfect here, but I have this vertical line. Ooh, I did a good job right on the ruler. It crosses here and here. Yes, a function. No, not a function. If the line passes through more than 1 point on the graph, it is not a function. Not a function. Not a function. Go to this one.
Yes, it's a function.
Lay your pencil down. Start next to Weiss's room. Slide it across to Hoosier's, keeping it vertical. Does it ever touch that graph more than 1 time?
No.
No. Yes, a function. No, not a function. Yes, a function. Yes, a function. Over here where the dots are. Lay your pencil down. Yes, a function. No, not a function. No? Yes?
Because there's no line.
Doesn't matter if there's a line. It's the graph. See this right here? How many dots is it touching? 2. So right here, if you drew a vertical line, it is touching 2 dots. So, not a function. Not a function. This one.
Yes. Yes. No.
What? Tell me where you have a problem with it. Here? How about here? 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 So function or no? Not a function. Okay? Now, on the computer, it'll still be nice. You'll be able to hold your pencil up against it, right? Against the computer screen. Again, on this one, do we have a lot of work to show here? I'm not expecting you to have anything to turn in. Hey, when you're done, what do you do? Alex, online home or any other homework, can you sit and do nothing? Can you sit and visit? No. Go to work.